Hello everybody, I hope you are fine. In this video, I'm going to share with you some points on coding, scales, missing values, and power analysis in PLS-SEM applications. So we start with coding and Likert scales, and the question here is that what is a good Likert scale? Well, a good Likert scale presents symmetry of points around the middle category, and also it should have clearly defined linguistic qualifiers for each category. Therefore, in such symmetric scaling, equidistant attributes will typically be more clearly observed or at least inferred. Another important point about symmetric and equidistant Likert scales is that basically these type of scales behave like interval scales, and their corresponding variables can be used in structural equation modeling. That is why, consistent with Hare et al. 2017, we have also recommended the use of symmetric and equidistant Likert scales to provide measurements for the latent variables in PLS applications. Now let's have a look at a few examples. Okay, first let me change my cursor. Okay, so there are three Likert scales here. The first one is a 5-point Likert scale starting from 1 to 5. And as you can see, we have point 3 or neutral in the middle. We have 2 points on the right and 2 points on the left. And as you can see, the distance between, for example, point 1 and point 2 is equal to the distance between point 2 and point 3, the distance between point 3 and point 4, and also the distance between point 4 and point 5. So here we have odd number of points, which is 5 in this case, and we have 2 points on the right, 2 points on the left hand side of the middle category, and basically it is viewed as a symmetric and equidistant Likert scale that is suitable for PLS applications, or basically a structural equation modeling. The second example is a 4-point Likert scale. So here we don't have the middle category. Basically it is not considered as a symmetric scale. And also note that the distance between point 2 and point 3 is double the size of the distance between point 3 and point 4, as well as the distance between point 1 and point 2. So not only this scale is not symmetric, but also it is not equidistant, and it is not recommended to be used for data collection in PLS applications. All right, let's have a look at the third one. Here we have 5 points, and in the first place it seems that it is symmetric, but in fact it is not, because the neutral point is not in the middle. So if you compare this scale with this scale, you would see that here we have neutral in the middle, we have 2 points on the right and 2 points on the left, but here we have neutral here, and we have 3 points on the right hand side of this point and 1 point on the left hand side. So basically it is not symmetric. Also, it is not equidistant, because if you compare this scale with this scale, you would see that the distance between point 3 and point 4, as well as the distance between point 4 and point 5 are equal. But here you cannot see that equality, and basically the distance between point 2 or neutral and point 4, which is agree in this scale, is double the size of this distance, the distance between agree and strongly agree. So this is because we have this problematic point here in between neutral and agree, which is causing the trouble. So basically this scale is not recommended for data collection as well. Okay, the next point is about single item versus multiple items constructs. And basically, as the literature indicates, it is very difficult to meet the statistical and methodological requirements of using single item constructs for the purpose of data collection. So in line with the previous literature, we have recommended the researchers to employ multiple item constructs to collect data for their PLS studies. Okay, with respect to missing values, we have also recommended the researchers to employ more advanced methods of handling missing values, such as expectation maximization method. Also note that I have provided here a quote from Tabachnik and Fidel 2013, page 63. Let me just read this for you because it is also very important. If only a few data points, say 5% or less, are missing in a random pattern from a large data set, the problems are less serious and almost any procedure for handling missing values yields similar results. So you should consider your sample size when it comes to making a decision for choosing a method for handling the missing values issues in your PLS applications. And lastly, always consider power analysis, not only for your basic analysis where you would like to estimate the parameters of your model, but also when you would like to run advanced analysis to extend the initial results in your study. For example, if you would like to run PLS to detect unobserved heterogeneity in your data, certainly you need to consider power analysis to determine the segment sizes based on observed R-square values in your model. So when it comes to extending the results using PLS, you have to consider power analysis one more time in your study. Okay, thank you very much for watching and I hope you like this video.